So the topic for today is quality control tools and techniques. Okay, and this is the topic of subject quality toolkit for managers. The code for this subject is KMBOM-03, and this course is designed for MBA third semester. And this is Professor Alok Singh from Ajay Kumar Garg Institute of Management, Ghaziabad. So you may refer some textbook or reference book or some blogs for further study. So here is the list of these references. Okay, like first is your textbook, and second and third are some good reference book that you may refer for further study, and rest are some good blogs or research paper links are there. Okay, so you may refer these blogs for further study. Okay, so now we would go for the 7 basic tools of quality. Okay, these all are known as the 7 QC tools, quality control tools. Okay, so we will discuss about the topic, that is 7 quality control tools. Okay, in today's lecture. So originated in Japan when the country was undergoing major quality revolution and had become a mandatory topic as the part of Japanese industrial training program. If you talk about Japanese quality movement, it was in the era of 1950s to 1980s. Okay, so originated in Japan, and when the country was undergoing major quality revolution and had become a mandatory topic as a part of Japanese industrial training program. So these tools, which comprised of simple graphical and statistical technique, were helpful in solving critical quality related issues. Basically, all these tools that I'm going to discuss are, these are basic 7 tools, and that are based on the statistics part. Okay, these tools are based on the statistics. Okay, so these tools were often referred as the 7 basic tools of quality because these tools could be implemented by any person with very basic training in statistics and were simple to apply to solve quality related complex issues. Means nowadays, if you talk about what are the basis of having the name of basic tool of quality, basically you may apply it on each. Okay, there are some basic statistics is applied here. Okay, so you can use it easily in your to manage your quality related complex issues. Okay, so that's why it is named as the basic tool of quality. Okay, next is 7 QC tools can be applied across any industry starting from product development phase till delivery. Okay, means you can apply it these tools anywhere. Okay, or whether in product development phase or in delivery phase. Okay, product delivery phase. So 7 QC tools even today owns the same popularity and is extensively used in various phases like Six Sigma. Six Sigma, there are the philosophies of Six Sigma like DMAC and DMADV, and in continuous improvement process like PDCA, plan, do, check and act, and lean management like removing waste from process. So you can use for Six Sigma also, or for continuous improvement Kaizen, or for total quality management, or for lean management, you can use 7 QC tool over there. Okay, so these are widely applicable tools. Okay, and if and these are very basic, means you can apply it on your real life problem also to improve the quality. Okay, so basically the first tool is histogram. So we most of us have been used this tool. So a histogram is a bar graph that shows the frequency data. So histograms provide the easiest way to evaluate the distribution of data. Okay, like histogram introduced by Carl Pearson is the bar graph representing the frequency distribution on each bars. Okay, here is an example, like the data table is given. Here is a bin and the frequency of that bin. Okay, so like 109.3, the frequency is 1, 112.5, the frequency is 2, 115.8, the frequency is 5. Similarly, various frequencies are given, so you can represent it or based on that histogram or bar graph. Okay, so here on x-axis you have taken bins, and on y-axis you have taken frequency of occurrence, that is 0, 5. You have taken here scale 5. Okay, So 0 to 5, 5 to 10, 10 to 15 is similarly you have taken here scale, and you have mentioned that means that bin by its occurrence based on the by using the tool that is histogram or bar graph. Okay, so this is the purpose of basically using this histogram. So the very purpose of histogram is the study the density of data in any given distribution and understand the factors or data that repeat more often. Okay, so if the data is repeating itself, so you can count the frequency and you can represent it on a graphical way, so that it could be easily understandable by any person. Okay, so histogram helps in prioritizing factors and identify which are the areas that needs utmost attention immediately. Means what is the critical factor that you may identify, like the frequency of this 125.57 is much higher, so you may identify the regions or you may track it. Okay, so that is possible just adopting this histogram. Okay, so this is the number one tool of basic 7 b7. Okay, and that is histogram. Next is Pareto chart. Most widely used tool is this. Okay, so Pareto chart are used to identify and prioritize problem to be solved. Even in your real life problem, you can also use this Pareto chart. Okay, so they are actually histogram added by 80-20 rule adopted by Joseph Juran. This is a he is a renowned quality guru, and he has given the concept of quality triology. Okay, that is given by Joseph Juran. So they are actually histogram added by 80-20 rule adopted by Joseph Juran. So and the Pareto chart is named after Wilfredo Pareto. Okay, so Pareto has started it and given the 80-20 rule. Means you should identify the 20% causes of 80% failure. Okay, and you should mitigate first those 20% causes, so that you can eliminate the 80% defect from your system. So Pareto chart revolves around the concept of 80-20 rule, which underlines that in any process, 80% of problem or failure is just caused by the 20% of few major factors, and which are often referred to as the vital few. So whereas remaining 20% of problem or failure is caused by 80% of many minor factors, which are also referred as the trivial many. Okay, so first identify the vital few and then work on the trivial many. Okay, so basically this is means you need to identify those 20% causes that are that are the cause of those 80% problems. Okay, so the very purpose of Pareto chart is to highlight the most important factors that is the region of major causes of problems or failure. Okay, so Pareto chart is having bar graph and line graph, where individual factors are represented by bar graph in descending order of their impact, and the cumulative total is shown by line graph. Here is an example. Okay, see, here is a example of types of customer complaints on second quarter 2005. Okay, so like the customer types of customer complaints are related with document, related with product quality, related with packaging, related with delivery, and related with other. So you have created a bar graph of those customer complaints. Okay, so now by seeing this bar graph, you may see that the most of the problems are related with the documents. Okay, so what are those 20% causes of this 80% problem of documents related problems or document related complaint? You need to identify those document complaints. Okay, so first you will address this document complaints. Okay, so the type of document complaint on second quarter 2005 are, so most of the complaints are associated with quality certificate error. Okay, another is quality certificate missing. Next is invoice error, packing list error, wrong quantity or other. So you will address first the quality certificate error. Okay, then quality certificate missing and vice error means first you will address this 20% cause that will that will eliminate this 80% of the problems of your customer complaint related queries. Okay, so this is the basis of this Pareto chart. So figure 1 shows how many customer complaints were received in each of the 5 categories. There are 5 categories like documents, product quality, packaging, delivery, and others. Okay, and the figure 2 takes the largest category. Like first you should consider the document. Why? The reason is that it is covering most of the portion. Means in bar graph, the frequency of document related complaints is much more higher than the other ones. Okay, so from figure 1, break it down into the 6 category of document related complaint. What are the various document related complaint? Like quality certificate error, quality certificate missing, invoice error, packing list error, wrong quantity, and this other. Okay, so these are the 6 categories that you have broken down, and now you have filtered those complaints. Means what is the frequency of various complaints. Okay, and now you have got that the quality certification error is the frequency of quality certificate error is much more higher than the other one. So first you will address the issue of quality issue related with the quality certificate error. So if all the complaint causes equal distress to the customer, working on eliminating document related complaint would have the most impact, and those working on the quality certificate should be most fruitful. So first work on this quality certificate error related issue, and after that you should eliminate the other error or other causes based on the Pareto principle. Okay, so this is the basis of Pareto principle. So Pareto chart help experts in following ways. Like you may distinguish between the vital few and trivial many. Means what are the vital few causes, and what are the various problems. Means what are the implication of those causes. Okay, so next is displays the relative importance of causes of problem. Okay, and help to the focus on causes that will have the greatest impact when solved. So basically you may identify those 20% causes that are responsible for 80% of problems in your organization. So you can eliminate those 20%, or you can mitigate the impact of those 20% causes to mitigate the impact of to mitigate the defects, or to eliminate the defects from your system. Okay, so this is basically Pareto chart. So this is another second tool of this quality control tool, B7, basic 7. Okay, next is cause and effect diagram. What is this? It is known as Ishikawa diagram also. Okay, because it is developed by Koru Ishikawa. So cause and effect diagram introduced by Koru Ishikawa helps in identifying the various causes or factors leading to an effect or problem, and also helps in deriving meaningful relationship between them. Okay, so the very purpose of this diagram is to identify all root causes behind a problem. Okay, once a quality related problem is defined, the factor leading to the causal of the problem are identified. Here is an example, like diagram relationships to reveal potential causes of problem. Example is given for what is causing production downtime. Okay, so this is a fishbone diagram, or this is cause and effect diagram, or this is Ishikawa diagram. Okay, because Koru Ishikawa has discovered this diagram, that's why it is known as Ishikawa diagram. Okay, cause and effect diagram is just because here is the cause and what are the effect impacts. Okay, किस वजहों से कुछ एक particular problem arise हो रही है. So that is basically the cause and effect diagram. Okay, and the structure of this diagram is looking like fishbone. So that's why it is known as fishbone diagram also. Okay, so like here is the example of production downtime problem. So what are the reasons of downtime? So it may be just because of equipment, okay, or material, or worker, or process. Okay, so if the problem is associated with equipment, so maybe it was due to maker or due to age of this equipment, that's why it is not performing well, or maintenance related problem would be there. So these are the possible means this is the cause, and these are the cause, various causes, and this is the effect. Means effect, impact is what, the downtime basically. Okay, so these are the various causes related to this production downtime problem. Okay, so equipment related causes are this: my maker, age, maintenance, etc. Next is this material. What is this materials related problems are like vendor or delivery related problems may be there, and workers like training, experience, and process like steps and sequences. So these are various causes. Okay, and that the effect of those causes are the production downtime problem. Okay, so you can maintain or manage a diagrammatic representation of all those problems that are occurring in your production facility by using this Fishbone diagram, or by using this Ishikawa or cause and effect diagram. Okay, so we further keep identifying the sub factors leading to the causal of identified factors till we are able to identify the root cause of the problem. And as a result, we get a diagram with the branches and sub branches of causal factors resembling to a fishbone diagram. Okay, so it is a tool for discovering all the possible causes for a particular effect. And the major purpose of this diagram is to act as the first step in problem solving by creating a list of possible causes. So in brainstorming session or in Delphi technique, it is most widely used tool. Means first work on this fishbone diagram, and after that you may discuss each and every problem. Okay, and or each and every causes of a particular problem. Okay, so you may first create this diagram, and after that you can use the brainstorming technique to identify that which is the most vital few causes that impacted most means that are responsible for more of the problems. Okay, so basically you can use this tool also. This is basic 7 third tool, cause and effect diagram. Next is check sheet. It is also known as tally sheet, and this is basic 7 fourth tool. So a check sheet can be the matrix, structure, table, or form for collecting data and analyzing them. Like you are if you are going to buy something okay from home, and you just maintain a list. Okay, so what is that? This is check sheet. Okay, the product or the service that you have is collected, you will take over it. Okay, so what is that? This is check sheet. So a check sheet can be a matrix, structure, table, or form of collecting data and analyzing them. So when the information collected is quantitative in nature, the check sheet can also be called as tally sheet. Means the if you are using quantitative check sheet, that is known as tally sheet, and qualitative check sheet, like as I have told earlier, if you are going to buy something, and you are generally maintaining a list of the commodities that you are going to acquire. Okay, so this is basically the check sheet or checklist. Okay, so the very purpose of a checklist is the list down the important checkpoint, or even in a tabular matrix format, and keep on updating and marking the status on their occurrence, which helps in understanding the progress, defect pattern, and even causes for defect. Like here is an example of this check sheet. Like there are various defect in your production facility. So defect type are major and minor, and you have identified it. Okay, so like these are defect like rusted items, items with scratch, dirty, broken cracks, main body dent, missing component, labeling error, and so on. So these are the various defect types. Okay, and you have noticed the occurrence of those defects. So you may see that the defect in supplied items, like On Sunday there is no defect. On Monday there are total count are 1 2 3 4, total counts are 4. Okay. On Tuesday there are two such defects there. Okay. Wednesday there is no defect. Thursday there are two such defects. Friday there is one defect, and Saturday there is no defect. So total count of the defect rusted item are 9 that you have get, okay, from your supplier. So defect in supplied item, you have get 9 defected rusted item from your supplier. Okay. On next means item with scratch, you have find that on Sunday you have got one item with scratch from your supplier. Okay. Dirty item, you have got one item dirty on Monday, and 3 on Wednesday, and 2 on Friday. So you can notice, or you can maintain a check sheet. Okay. And you can also see that we have got total number of defects, 2 on Sunday, 9 on Monday, 12 on Tuesday. Okay. So all these data you can get by or you can access by using the checklist, okay, or check sheet or tally sheet. Okay. So this is the uses of this check sheet, and that is fourth tool of this basic 7 tool, and that is also known as tally sheet if you are using quantitative data. Okay. Next is control chart. What is control chart? Basically, it is a graph used to study how the process changes over time. Like what is the mean and upper controllable limit, lower controllable limit, and you will map the process over there. Okay, so the data are plotted in time order, and a control chart always has a central line for the average, and upper line for the upper control limit, and the lower line for the lower controllable limit. Like here is the example. Okay. Like if you are measuring something, okay, and you want that mean should be 110. Okay. And if you have, like you are weighing, okay, and you are giving some product by weighing to your customer. Okay. So like if the weight is 110, that the customer is expecting to get. Okay. And when you are means weighing it all the time, you will get following patterns. Means upper controllable limit, if customer is asking for 110 gram, so the maximum upper controllable limit is permissible limit, that is 120. For example, you have agreed with your customer that we will I may maximum give you to the 120. Okay. And minimum is the 100. So basically the process average is 110, and upper controllable limit is 120, and lower controllable limit is 100. Okay. And then you will map that every time when customer arrive and said you to weigh the commodity, then you will wait and you will get following pattern. Okay. So this is basically the control chart. Okay. Means extreme low and extreme high is not permissible by you as well as your customer. Okay. If you would weigh more than 120, means it would be loss for you. Okay. And if you would weigh less than 100, then it would be loss for your customer. So basically both will not permit such deviations. Okay. So you need to control it, so that's why it is known as the control chart. Okay. So the control chart is also called as the Sewhart chart, named after Walter R. Sewhart. This is also a renowned quality guru, and is basically a statistical chart which helps in determining if an industrial process is within control and capable to meet the customer defined specification limits. Okay. And the very purpose of control chart is to determine if the process is stable and capable within current conditions. Okay. So in control chart, data are plotted against time in one x-axis, and control chart will always have a central line, average mean, and an upper line for the upper control limit, and as a lower line for the lower controllable limit, as I have told earlier in the example. So these lines are determined from the historical data. Okay. Means if you are weighing and your customer is asking for 110 gram, So minimum permissible limit is 100 gram and maximum permissible limit is 120 gram. Okay, so all time when you weigh, you will try to get it in the range of 110. So that is basic purpose of using control chart. Okay, to notice the deviation, and if they are, you need to maintain it or manage it by using the control chart. Okay, next next quality control tool is basic 7 quality control tool is scatter diagram. So a scatter diagram is a tool for analyzing the relationship between two variables. One variable is plotted on horizontal axis, means x-axis, and other is plotted on the vertical axis, that is y-axis, and the pattern of their intersecting points can graphically show the relationship pattern. So a scatter diagram is used to prove or disprove cause and effect relationships. Okay. So scatter diagram or scatter plot is basically a statistical tool that depicts dependent variable y and independent variable on x-axis. Plot as dot their common intersection points. Joining these dots can highlight any existing relationship among these variables, or an equation in format y is equal to fx plus c, where c is an arbitrary constant. Basically, why you using scatter diagram? To see the trend of the data. Okay, like here are the some example, like positive linear correlation. This data shows the positive linear correlation, means the data is moving upward. Okay, negative linear correlation means the data is moving downward. Like nowadays, if you see the trend of COVID cases, okay, so they means the cases were become lower, and then now they have shifted towards the upper side. Okay, so this is the basically the scatter diagram is used to show the trend of the data. Okay, whether it is moving upward, whether it is moving downward, or whether there is no correlation in between the data, like such diagram, and whether there is a non-linear correlation, like this is polynomial or some quadratic function, or some exponential or some logarithmic function are there. So you can identify the trend of the data by using this scatter diagram. So it is also a most widely used tools nowadays. Okay, so the very purpose of scatter diagram is to establish a relationship between problem and causes. Those you have identified by using those cause and effect diagram. So you can now identify the relationship between, means what is dependent variable and what are the independent variable, and what are the attributes, means what are the relationship in between these two functions you can identify. Okay, and the relationships can be linear, curvilinear, exponential, logarithmic, quadratic, polynomial, etc. And stronger the correlation, stronger the relationship will hold true. Okay, so the variable can be positively or negatively related, defined by the slope of equation derived from the scatter diagram. Okay, so this is also another important tool that you may use while dealing with the quality related problems. Okay, so the next and last tool of basic 7 is stratification. Nowadays we are doing research and we are clustering the data, okay, in different segments. So that is what basically stratification. So a technique that separates data gathered from a variety of sources so that the patterns can be seen. So the stratification is the process of dividing members of the population into homogeneous subgroups before sampling. So the strata should define a partition of population. Okay, and that is, it should be collectively exhaustive and mutually exclusive. So every element in the population must be assigned to one and only one stratum. Like you have multicolor balls, okay, multiple balls of different colors. Okay, so and you need to sort balls based on their colors. So you may put red balls on red section, okay, green balls on green section, okay, yellow ball on yellow section. Okay, so that is basically the stratification, means the ball that is belong to a particular group will move to that group. So that is basically the stratification. Okay, and if you see some blocks, you will find flow chart or run chart in place of stratification. So if you see, there are these two tools are also there on 7 QC tools. Okay, so some list replace stratification with flow chart or run chart. Okay, so stratified random sampling. So see here, like if you have a red ball, okay, so group 1 red, okay, yellow, then group 2, okay, and green, then group 3, blue, then group 4. So this is basically, and from these groups you can take sample, okay, by using the simple random sampling. Okay, or so you can get some red balls, or you can pick some red balls, or pick some this yellow, some green, some blue. Okay, so this is basically the stratification. This is the use of stratification. So these are the 7 tools that you may use your to deal with your quality related problems. So for further study, or here are some references. First is your textbook, second and third are some good reference books, and rest are some good blogs and link of some good research papers that you may access for further study about the topic, that is 7 QC tools, quality control tools. Okay, so if you have any doubt or query, you may ask. Okay, thank you.